Hi, good morning, guys. See, in today's class, we'll discuss quantum numbers, which is a part of atomic structure. See, what is the significance of quantum numbers? So, by seeing this diagram, what you can say? So, here, so many people we have. So, from that, you have to find the person whom you want. Okay. So what? It's like asking an address about a person. So, similarly, the quantum numbers will give you address of an electron. Okay, so how they will give address of an electron? Like for example, suppose one of your friend is studying in town. Okay, so you want to meet him. So first what you will do? So you will go to the town. So from your place you will go to the town. Okay, in that town your friend is studying some X college or X school. So in that school you will enter into the school, and in that school you will have number of blocks. Okay, so in number of blocks, you will go to some particular block. So that is let it be Y block. Okay, your friend classroom is in Y block. So in that Y block, so your friend is classroom is in a second floor. So what you will do? You will enter into that Y block, and in Y block, you will enter to second floor. In the second floor, you can find the classroom of your friend. And in that class, you can find your friend. So like this. So address of an electron can be given by these quantum numbers. From where these quantum numbers are derived? So these quantum numbers are derived by using a equation, so which is called as Schrodinger wave equation. Okay, so that is Schrodinger. Schrodinger wave equation. So what is the Schrodinger wave equation is? So it deals about probability of finding electron along x, y, and z axis. So the Schrodinger equation can be written as what? So the Schrodinger equation can be written as dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equal to 0. So this is the Schrodinger wave equation. So in this equation, psi stands for wave function, and this E stands for energy, and V stands for velocity, and the M stands for mass of the electron. Okay, so from this Schrodinger wave equation, they derived three quantum numbers. What are the three quantum numbers are? So, okay, so we have how many quantum numbers? We have four quantum numbers. Among the four quantum numbers, so the first one is principal quantum number. This is indicated with the L. And second one is azimuthal quantum number, and this is indicated with L. And third one is magnetic quantum number, and this is indicated with the M. And fourth one is spin quantum number, and this is indicated with the S. So these are the four quantum numbers we have. Among these four quantum numbers, these three quantum numbers are derived from the Schrodinger equation. What are the three quantum numbers? Principal quantum number, azimuthal quantum number, and magnetic quantum number. So these quantum numbers are obtained by using this wave equation. So now we see what are the significance of these quantum numbers in detail. Okay. So what is the first one? So the first one is principal quantum number. Principal quantum number. So what about it deals? First one, it deals about size and energy of the orbital. And next significance and next thing. So it is indicated with integer like 1, 2, 3, 4 or K, L, M, N. Okay. So number of subshells is n square. So that is number of orbitals in particular shell is n square. So like what does it mean? See, for example, if this is your nucleus and this is your first orbit and this is your second orbit and this is your third orbit, for example. So in the first orbit, so that is if n is equal to 1. If n is equal to 1, only oneness orbital only will exist. So that means n square. If the value of n is equal to 1, the value of n square is what? So this is nothing but 1 square, 1. If the value of n is equal to 2, so that is coming to second orbit. In second orbit, we have 2s and 2p. These 2p have again 3 shells, px, py, pz. So this is the case of n is equal to, we have 2s and 2p. What is n square here? So n square is equal to 2 square. So this is 4. So that means how many subshells we have? 1 s orbital, 1 px orbital, 1 py orbital, 1 pz orbital. So we have 4 orbitals. If n is equal to 3, we can have 3s, 3p and 3d also. So here 1, here 3, here 5. Total how many? 9. So that is n square is what? 3 square, 9. Okay. So total number of orbitals is n square. And d. So the number of electrons, the maximum number of electrons can accommodated is equal to 2n square. So in particular orbit, the maximum number of electrons can accommodate is 2n square. How you can say the maximum number of electrons can accommodate is equal to 2n square? See, in the first orbit, we have only one s orbit. So this can accommodate 2 electrons. So that is 2 into 1 square. So this is nothing but 2. In second orbit, what we have? We have 1, 2, 3, 4. Okay. So n square is what? N square is 2 square. So that is nothing but 2 into 4, 8. So how? So here 2 electrons can accommodate and here 6 electrons can accommodate. In each cell 2 electrons can accommodate, right? So like this. Total number of electrons can accommodate is 2n square. After the principal quantum number, so the next one is azimuthal quantum number. This is indicated with the L. What is the significance of this azimuthal quantum number? This azimuthal quantum number deals about shape of the orbital. Okay, so the values of L, that is azimuthal quantum number, varies from 0 to n minus 1. So that means the value of L is always less than n. Okay, remember this one. And third one, the orbital angular momentum. So the orbital angular momentum can be calculated by using formula. What is that formula? Square root of L into L plus 1 h by 2 pi. So you can write h by 2 pi as h bar also. Okay, so then what? So the orbital angular momentum is, you can write square root of L into L plus 1 h by 2 pi you can write. Okay, or square root of L into L plus 1 h bar you can write. Okay, if the value of n is equal to 1, So the value of L will be what? 0. How the value of L will be 0? So the value of L varies from 0 to n minus 1. So n minus 1 is nothing but what? 1 minus 1 is 0. If the value of L is equal to 0, this corresponds to s orbital. So the shape of s orbital is spherical. If n is equal to 2, so that is the value of L is equal to 1. So it indicates p orbital. So the shape of p orbital is dumbbell. If n is equal to 3, so the value of L is equal to 2. This indicates d orbital. This is nothing but double dumbbell. Okay. If n is equal to 4, so the value of L is equal to 3, and this indicates f orbital. The shape of f orbital is quadradumbbel. Okay, so these are the shapes of orbitals. So S orbital spherical, P orbital dumbbell, okay, and D orbital double dumbbell, and that is what? Quadradumbbel. Okay, so this is deals about shapes of the orbitals. Okay, and the next one is magnetic contour number. Okay, so what is this magnetic contour number? 3. Magnetic quantum number M. What is it deals? It deals orientation of orbitals in space. So here the value of M varies from minus L2 plus L, including 0. And how many values of M will be there? So the value of M is equal to what? 2L plus 1. So that means if L is equal to 0, so the value of M is equal to 1. If the L is equal to 1, so the value of M is equal to 3. If the value of L is equal to 2, this is 5. If the value of L is equal to 3, the value of M is equal to 7. So for M is equal to 1, we have s orbital. So the probability of finding electron is same in all directions. What you can say? It is unidirectional. And for M is equal to 3, what are the values we have? So minus L2 plus L, minus 1, 0, plus 1. And for L is equal to 2, we have 5 values of M. So that is minus 2, minus 1, 0, plus 1, plus 2. And for L is equal to 3, the M have 7 values. What are they? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So these are the values of L. So that means how many orientations we could have? Let's see. See here. So this is for s orbital. This is unidirectional. So that means in all directions the probability of finding electron is same. And this is p orbital. So for p orbital, we have how many values of M? We have 3 values. So that means 3 orientation should be there. So px, py, pz. Okay, so 3 orientations we have. And for L is equal to 2, so the values of M is equal to 5. And this is for d orbital. See how many orientations we have? So we have 5 orientations. And L is equal to 3. So how many values of M we have? 7 values. So that means 7 orientations you should have. Okay. Okay, so like this, so the values of M deals about orientation of orbitals. Okay, so whether they are in x, I mean oriented along x axis or y axis or z axis. Okay, so like that. And the next one is spin counter number. So the spin counter number, so this is what independent one this is. So this is not from any, that means this is not from the Schrodinger wave equation. Okay. So next one is spin counter number. Okay, so it deals about spinning of electron. Whether it is spinning in clockwise or anti-clockwise. If it is spinning in clockwise, you can say minus of. It is spinning in anti-clockwise, you can say plus of and minus of. See, according to UPSC, there is no particular rule like whenever the electron rotating in clockwise direction, you should name it as plus of, and whenever the electron is rotating towards anti-clockwise, it is minus 2. So you can call this one as minus 2 and this one as plus of. Okay, sorry, minus of and plus of. So like this also you can say. So the difference of spin quantum number is what? So the difference of spin quantum number is nothing but 1. Okay, so that means spinning, it deals about what? It deals about spinning of electrons, whether the electron is rotating towards clockwise direction or anti-clockwise direction. Okay, then see how it is. So this is like this. Okay, plus of and minus of.